I'm going to talk about division with respect to decimals. Okay? First, I'm going to talk about the division of decimals by powers of 10. Then I'm going to talk about division of decimals by other decimals. All right? So, to divide a decimal by a power of 10 that's 10 or bigger, okay, what you do is you move the decimal a certain number of hops to the left. The number of hops is equal to the number of zeros in the power of 10. So for 4.5 divided by 10, you would move the decimal point 1 hop to the left, and you would get 0.45. For 4.5 divided by 100, you would move the decimal point 2 hops to the left, and then you'd get 0.045. Okay? Now, if you have a power of 10 less than 1, like 0.1 or 0.01, then you move the decimal point the same number of hops to the right that there are numbers to the right of the decimal point in the power of 10. Okay, so for example, to divide 4.5 by 0.1, that's going to involve 1 hop to the right, so you get 45. 4.5 divided by 0.01, that's going to involve 2 hops to the right, so that'll give 450. Now, let me have you do a few examples. Would you please find 0.12 divided by 0.01, 10.3 divided by 100, and let's just do those two. So pause the video and work those out, please. Okay, so I'll go ahead and work them out as well. So for the 0.12, I'm going to move it 2 hops to the right, and that'll give me a 12. For the 10.3, I'm going to move it 2 hops to the left, so that'll give me 0.103. All right, now let's discuss dividing a decimal by another decimal. So in the recipe I'm going to show you, the first step is to make the denominator to turn it into an integer. So for example, if we were dividing 1.25 by 2.5, you would first multiply the top and bottom by 10. Okay, and that would turn the denominator into an integer. All right. Likewise, if you were dividing 4.392 by 0.36, for this example, you would multiply the top and bottom by 100, because it would take 2 hops to turn 0.36 into an integer. Okay? And so multiplying the top and bottom by 100, we would get 439.2 divided by 36. Okay, so that's step 1. Turn the denominator into an integer. Now, the next step is to do long division as if the numerator and denominator were both integers. Okay, the numerator may not be an integer, but you're still going to do long division as if it was an integer. So, for example, for the 12.5 divided by 25, we do 125 divided by 25. Okay, we'll put the decimal there, but we're gonna act like it's not there. So 25 goes into 125 5 times. Okay, and then it divides evenly, so we're done. Okay, but the answer is not 5. Okay, now what we do is we put another copy of the decimal point above where the old one is. So right there, and so the answer is 0.5. Okay? Let me use this same method to do the second example. So I'm going to do, I'm going to write 439.2, but I'm going to act as if I'm dividing 4,392 by 36. So let's see, first I put a 1, then subtract 36, and that gives a 7. Then I drop the 9 and put a 2, that gives a 72. 79 minus 72 is 7, drop the 2, put a 2. Now I subtract 72 and I'm done. Okay, so once again I put a new decimal point above the old one, and so the answer is 12.2. Okay? Now, if you had other signs, if you had negative numbers, you would ignore those as well, and then you would correct your answer. You'd make it have the correct sign after you had done these steps. Okay? You should know that if both the numerator and denominator have the same sign, your answer will be positive. If they have different signs, your answer will be negative. Okay, so just ignore the signs in the answer until the very end, and then make that evaluation and correct the sign of the answer. Okay? Now, I'd like you to do an example. All right, would you please do 41.82 divided by 3.4 and 48.72 divided by minus 1.4. All right, so pause the video and work those out now, please. Okay, so I'll go ahead and do it. So I will multiply the top and bottom by 10, first of all. Then I will do long division as if the decimal point was not there. So we'll start with a 1. Then I'll add a 2 to the answer. Then let's see, 3. 3 times 4 is 12. Carry the 1, 10. And so the answer is 12.3. Okay? For the second example, I will ignore the negative sign for now and multiply the top and bottom by 10. So 487.2, and well, I'll get minus 14. I'll still add the minus to the bottom, but actually it's when I do the division that I'm going to ignore it. So and then add it back later. So I'm going to act as if I'm dividing 4,872 by 14. And so, let's see, we'll start with a 3. 3 times 14 is 6 times 7, that's 42. So I get 6, drop the 7. Let's see, 7 goes into 67 9 times, so 4. 4 times 4 is 16. 1, carry the 1, makes a 5. So 11, drop the 2, and let's see, 7 goes into 1, 1, 2, how many times? 1, 6, 16, so I'm going to put an 8 for 14. So 8 times 4 is 32, carry the 3. 1 times 8 plus 3, 11. All right, so then we put the new decimal, and our answer is 34.8. But now I add the minus, can't forget that. So my answer is minus 34.8. Okay? Now, let me end by making a comment about something that you might notice when you do similar division calculations, okay, using long division. So it's not always going to be the case that the division is eventually going to end, okay? You can have a situation where instead of having a decimal that stops, that the numbers terminate, as it's called, you have a pattern that keeps repeating, okay? So for example, if we divided 0.1 by 0.3, we could convert that to 1/3, and then we could divide 3 into 1. And what we would notice is that we would keep getting 1s. Okay, and it would never stop. Okay, now, by the way, if you need to keep adding zeros when you do long division, that is perfectly fine. Okay, so you saw that I started with 1.0, and then I added a few more zeros. So I didn't emphasize that before, but that's perfectly fine if necessary to keep going. So here we would get 0.33, and then we keep adding 3s. Okay, so there's two ways to deal with that. You can either stop at some point and then you'll have an approximate answer. Maybe 0.33 is adequate. Maybe even 0.3 is good enough for your purposes. Okay? Another thing you could do is the following. You could put a bar above the pattern that's repeating. Okay? So we have just the single number 3 repeating. So 0.3 with a bar over it is equivalent to 1/3. Okay? It's the exact answer. It's a representation of the exact answer. All right, so let me have you do an example that repeats, and I want you to put a bar over the piece that's repeating. Okay, and I also want you to give an answer, an approximate answer that has 2 decimal places to the right of the decimal point. Okay, so do both of those procedures, the approximation and then adding the bar. Okay, I'll give you a warning. There's the pattern involves a few numbers. Okay, it's not just going to be a single number like the 3. So do 0.4 divided by 0.7. Okay, work that out now, giving me the approximate answer and then the answer with the bar on top. So pause the video now, if you like, and do it. Okay, so I'll go ahead and work it out. So multiplying by 10, I get 4/7. So as I said, you can add zeros, as many as necessary. Okay, so 47 goes into 45 times. 7 goes into 57 times. 7 goes into 10 one time. 7 goes into 34 times. 7 goes into 22 times. 7 goes into 60, how much times is it? 8. Okay, and we finally got to a 4, which is, and then I could drop down to 0. And we finally got to the same situation I started in, right? So that means I'm going to keep getting 571428 over and over again. Okay? Then, of course, I add my decimal in my answer. So if you need an answer with 2 numbers to the right of the decimal point, you can round and get 0.57. That's fine. Okay, or for the exact answer, you can say 0.571428 with a bar over the 571428. All right.